All right, class, settle down, settle down. So today we are going to talk about a very fascinating organ. It's a bit of a marvel, really. It's like a factory and, well, a ticking time bomb hidden right inside all of us. I am talking, of course, about the pancreas. So, let's begin. First, a question for you all. But Joe, think about this for a second. What organ in our body is so incredibly powerful, so packed with potent enzymes, that if something goes just a little bit wrong, it can literally digest itself? The answer, as you've probably guessed, is the pancreas.
So, here's our game plan for today. First, we'll get properly introduced to the pancreas. You know, what it is, what it does. Then, we'll get into the more serious business. What happens when things go wrong? From a dangerous inflammation to, of course, the big C, cancer.
Okay, let's jump into Section 1, Meet the Pancreas. The best way to think about this organ is as a super efficient, dual-purpose factory tucked away deep inside our abdomen. So what is it? Well, it's this complex, lobulated gland sitting right behind the stomach. And its name, from the Greek, literally means all flesh. Sounds kind of simple, doesn't it? But trust me, its function is anything but simple. It's one of the most complex players in our entire body.
And this slide really shows you why. It's a two-in-one deal. The exocrine part, that's the vast majority of the organ, 80 to 85%, its whole job is to be a digestive juice factory. But then you have this tiny little part, just 1 or 2%, the endocrine part, those famous islets of Langerhans. They're the hormone specialists, controlling our blood sugar with insulin and glucagon. Two totally different and absolutely vital jobs.
All right, now let's move on. Section 2, A Tale of Two Ducts. This is where we start to see what happens when the factory's plumbing system isn't put together correctly right from the very beginning, during development in the womb.
And you might be surprised to hear this, but the most common of these developmental glitches, something called pancreas divisum, is actually found in up to 10% of the population. That's a huge number of people walking around with this little anatomical quirk.
So what exactly is the issue? Look here. Normally, during development, two ducts fuse together to make one big main drainage pipe. But in pancreas divisum, that fusion just doesn't happen. So now the bulk of the pancreas has to drain all its juices through a much, much smaller accessory pipe. I mean, imagine trying to drain a huge factory tank through a tiny little straw. It's a recipe for a major backup, right?
And that backup can lead to a total system failure. Which brings us to Section 3, the fire within. This is where the pancreas literally turns on itself in a condition we call pancreatitis.
Now, this is the key concept you must understand. Pancreatitis is autodigestion, those incredibly powerful enzymes that are meant to break down food in your intestines. They get activated prematurely inside the pancreas itself. The organ starts to digest its own tissues. It is a full-blown internal crisis.
Now, our body is pretty smart, okay? It has multiple safeguards to stop this from happening. First, the enzymes are made in an inactive form. Think of it like a weapon with the safety on. They're only supposed to be activated by an enzyme called trypsin, and that's only supposed to happen far away, safely inside the small intestine. And just in case, as a final failsafe, the pancreas even makes its own trypsin inhibitors.
But when those safeguards fail, maybe because of a blocked duct or heavy alcohol use or some other injury, this terrible cascade begins. The initial injury just overwhelms the protective systems. Trypsin gets activated inside the pancreas, and it sets off a chain reaction, activating all the other enzymes. What follows is just a chemical firestorm of tissue destruction and massive inflammation. In this image, this shows you the devastating result. This is not just a little bit of swelling, class. It's a war zone. The tissue is destroyed, blood vessels are eaten away, causing all this bleeding, and the organ turns into this necrotic, digested, red-black mass. This is that fire within we've been talking about, in its most literal form.
And from this kind of damage, an even scarier threat can emerge. Section 4, The Silent Killer. BACO, pancreatic cancer, is truly one of the most difficult challenges we face in modern medicine.
Just look at this number, 12%. Just let that sink in for a moment. That is the 5-year survival rate. It's one of the deadliest cancers there is, and there's a very specific, tragic reason for that.
See, the problem isn't just that the cancer is aggressive. The real issue, the reason it's so deadly, is that it's silent. It's a ghost. More than 80% of patients are diagnosed only after the tumor has already spread, and it's no longer possible to remove it with surgery. It just grows and grows without any symptoms until it is far, far too late.
And this terrible process doesn't happen overnight. No, it's a step-by-step progression of genetic mistakes. It usually starts with an early mutation, often in a gene called KRAS. Then, over time, more and more of the body's emergency brakes, these critical tumor suppressor genes like P16 and P53, they get switched off. This allows the cells to grow completely out of control until they become a full-blown invasive cancer.
And here you can see what it actually looks like. It is not some neat, contained little ball. It's a hard, star-shaped, grayish-white mass. It is intensely invasive, sending out these little tendrils that just infiltrate and strangle all the healthy pancreatic tissue around it.
So, this leaves us with the most important question of all, the one that researchers all over the world are desperately trying to answer. If this disease does all of its deadliest work in complete silence, if 80% of these cancers are found only when it's too late, then how do we finally learn to unmask medicine's silent killer? That is the challenge that we, and you, must one day overcome.